Welcome back to Zuluwa Consultants. In this video, we want to learn how we can answer this question under the topic nuclear chemistry. The question reads, there are 200 grams of cobalt 60 that has the half-life of 14 years. How many grams of cobalt will remain after 126 years? Before we can look at this question, we want to remind you that Zuluwa Consultants has produced a lot of videos under the topic nuclear chemistry. You do well to watch a series of those videos that will help you to see different examples and how they have been worked out. So in this video, for us to answer this question, we are going to use these two equations. Now, let's get some information from the question. The first information we can get is the initial mass, that is 200 grams. We can also see the half-life, that is 14 years. Then we can also see the time at which they want us to find the mass. So the time at which they want us to find the mass is 126 years. We don't know the mass, so the NT is not known. Then we also don't know the reaction rate constant. For us to find the reaction rate constant, we'll use the second equation, and when we make it the subtotal formula, we'll say reaction rate constant is equal to 0.693 divided by the half-life. So we have 0.693. Our half-life is 14 years. So let's divide 0.693, dividing it with 14. We are getting the answer of 0.0495. So this is the reaction rate constant at which this cobalt was decaying. So we have the information here. So what we need now to find is the mass at this 126 years. Now we are going to use this equation, that is the first equation, for us to find the mass. So the mass we want to find, it is this one, which is the denominator in the bracket. Now, according to the rule of natural logs, when you have a division, is same as the natural log of the initial mass minus the natural log of the mass at a given time is equal to the rate constant multiplied by time. So we have expanded this equation. Now we can put in the values in this equation. So we have the natural log of the initial mass is 200 minus the natural log of the mass at that time. Then we have the rate constant of 0.0495. We are multiplying this with a time of 126 years. So let's find what is the natural log of 200. The natural log of 200 is giving us 5.298 minus natural log of NT is equal to what is 0.0495 multiplied by 126. It is giving us 6.237. So the 5.298 can cross the equal sign. We'll have negative the natural log of NT is equal to 6.237 minus 5.298. So then natural log of NT is equal to 6.237 minus 5.298. It is giving us 0.939. We can divide both sides by -1, so that we remain with a positive natural log there. So the positive natural log is equal to -0.939. I am now going to move this on top here so that we continue with our journey. So the natural log of NT is equal to -0.939. We are interested in NT, so we need to remove the natural log from this expression. We are going to borrow one rule of natural logs, which says that the exponential function of natural log of x is equal to x. This simply tells us that the exponential function and the natural log simplifies so that x becomes equal to x. So if we use this rule, we are saying when we use the exponential function of natural log of NT will be equal to the exponential function of -0.939. So the natural log and the exponential function will simplify. Then the NT will be equal to the exponential function of -0.939. It is giving us 0.39 grams. So this becomes the mass that will remain after 126 years. We hope this video has been very helpful. Do not forget to subscribe to our YouTube channel and follow us on our Facebook page if you have not done so. Thank you so much. See you next time.